Alright, so what we're going to be looking at in Unit 5, Lesson 7 is something called percent composition. And we're going to do a couple of labs on this, but let's just quickly run through what might be a review for many of you, how to determine the percentage of something. And in chemistry, it's a little bit different. Give you an example of how it's different. When we're looking at percent composition, we're looking at it based on the masses of the substances. So for example, if I said to you, what's the percentage of, if I had a fruit basket and in the fruit basket I had 5 apples and 7 oranges, I might say to you, what's the percentage of apples? And there's a formula to do that. In chemistry, we do it a little bit differently because it is percentage, but we're looking at not how many you have of each object, but the masses of the objects. So it's a little different. So here's an example of what you might normally find. So for example, if you want to find the percentage of boys in the class, our class, any class, you'd have to find two things. First of all, you'd have to count how many total number of students there are. So I think in our class there's 26 or 27. And then count how many boys there are. So let's say there's 13 guys or boys in the class. So it would be 13 divided by, let's say, 26 times 100. That would be approximately 50%. But that's not percent by mass. That's the percentages based on the numbers. In chemistry, we don't do that. We're looking at percentage by mass. So here's how it is different. The formula for percentage composition is on reference table T. And the formula is, let me write it down here. The formula for percent composition is percent composition by mass is what we call the part over the whole times 100. So whenever you're doing a percent composition, there obviously your answer is going to come out as in a percentage. The whole would be the total, and the part would be the piece that you're looking for, the mass of the part that you're looking for. So here's one way of doing it. We have, let's say, we have a sample of this compound. The entire sample has a mass of 14.8 grams. Out of that 14.8, 3.8 grams of it is iron, and 10.97 grams is bromine. If you take these two and you add them up, they're going to come out to that. So the question says, what is the percent of bromine? So let's go and look at the equation. The whole is the total. The total of the sample is 14.80 grams. And since we're looking for the bromine part of it is 10.97. So it's 10.97. We're going to divide that 10.97 divided by 14.80. Of course, the 10.97 goes in the calculator first, and I believe it's going to come out to 74.12% bromine. And again, you don't have to worry about significant figures. Technically, you should have two numbers or 4 numbers in the answer because you have 4 significant figures here and 4 significant figures here. But so that's how you do percent composition, and that's based on, for example, this might be experimental data. You might have a lab where you have a sample of a mixture. The mixture is composed of 2 elements, iron and bromine, and you separate the 2 elements like we did in the lab earlier in the year. And you could find the percent by mass of that mixture, but you should also be able to do the percent by mass in a compound. So for example, if I said to you, if here's the compound right here. Now it's a little bit of a strange compound. It's ammonium nitrate. It's definitely a ternary compound. It wants you to find the percent by mass of nitrogen. So it wants you to find out how much of the nitrogen is in the compound. What percentage of the mass of this whole compound is nitrogen? So your first step is going to be to find the gram formula mass of the compound. And we did that before, so you have nitrogen, you have hydrogen, and you have oxygen. And you go back to the formula and you say, okay, I have 1 nitrogen here and 1 nitrogen here, so I actually have 2 nitrogens. I have 4 H's, and I have 3 oxygens. I go to the periodic table. The nitrogen mass is 14. We know hydrogen is 1. And oxygens are 16. So let's multiply these. That comes out to 28. This comes out to 4. And this comes out to 48. So this is 16, 20, 0, 6. It comes out to 80 is the total. That is what we would call the whole. That's the total mass of the compound. That goes on the bottom. So the percentage of nitrogen is going to be 80 at the bottom. And we want to find the percentage of nitrogen. So the part is going to be the part that represents the nitrogen, which is 28. So we're going to divide that and multiply by 100. So let me get my trusty calculator. So I have 28 divided by 80 times 100 comes out to, times 100, comes out to about 35% nitrogen by mass. And that's how you do percent by mass. If you look at the question at the bottom, it says, and this is a little bit tricky, it says which species contains the greatest percent by mass of hydrogen. So what you have to do is you have to go through each compound and determine which one's going to have the largest percentage by mass of hydrogen in it. Now, a couple of things you could do. If you look at this, if you're looking for the one that has the most hydrogen, you want to look at which one has the most mass of hydrogen as opposed to the oxygen. Well, if you look at this, there's only one oxygen, which is 16, and one hydrogen. In this one, you have 2 hydrogens and 1 oxygen. So already you have more hydrogens in this one. This one has 3 hydrogens as opposed to just the 16 for the oxygen. So this is going to definitely be the H3O is going to have the largest percentage of mass of hydrogen. And here are the numbers at the bottom if you wanted to do that. And that's it for percent composition. There is a second part to this, which we'll do in the next